11 paper. Now, I don't normally go through these papers, but I have actually included this question in one of my IGCSE end of topic worksheets on equations and indices. And this particular question here is, I think, question number 21 in that worksheet that I've made. And, you know, I've included this question in there as like a extension type of question. I mean, you might not find something of this type, although this is well within the IGCSE syllabus, but it's a bit more kind of like, I'd say, advanced than what you might find. Okay, so the concepts needed to solve this question are taught in IGCSE, but it might be a bit more difficult than most questions you would find. So that's why I've included it as like an extension question towards the end of the paper. So one of the students has asked me to explain how to solve this question, and I'll do so. Okay, so this is from the additional mathematics paper from October-November 2015, paper 1-3. Now, as I said, I don't normally answer questions from this. I normally do IGCSE or AS A-level papers, but I'm going to answer this for now. So it says, given that 2 to the power of 2x minus 1 plus 4 to the power of x plus y equals 128, and 9 to the power of 2y minus x over 27 to the power of y minus 4 equals 1, find the value of each of the integers x and y. So we know x and y are going to be integers, that's one thing. So in the end, if we get x and y to be like fractions, not whole numbers, then we know that there's something wrong with our answer. So that's a little clue that we'll be able to tell. Now, these are exponential equations. Why are they called exponential equations? The reason they're called exponential equations is because the variables are in the power or the exponent. So whenever we deal with exponential equations, we try to write them in such a way that the bases are expressed as the same number. So if we look at the first equation that we're given, which is 2 to the power of 2x minus 1 times 4 to the power of x plus y equals 128, we look at the bases and we try to figure out, is there a way of us expressing these bases as the same number? And after a little bit of thought, you'll realize that 4, I can express it as 2 to the power of 2. And 128, I can express it as, well, I know 2 to the power of 5 is 32, 2 to the power of 6 is 64. I can express it as 2 to the power of 7. Okay, so I can express all of these with the same base. And if I do that, this will stay as 2 to the power of 2x minus 1. But 4 is going to become 2 squared. So I'll have 2 to the power of 2 raised to the power of x plus y. And that's equal to 128, which is 2 to the power of 7. So now, what I can do here is I can say this is like 2 to the power of 2x minus 1 times, and now I can multiply the powers. I know that one of the laws of indices is a to the power of m to the power of n. If I multiply, if I have something raised to a power to another power, I have to multiply the powers. So this will be the same as 2 to the power of 2x plus 2y. Multiply 2 by x plus y. And that's equal to 2 to the power of 7. And I also know that when I multiply two numbers in index form with the same base, like a to the power of m times a to the power of n, I add the powers. So I can add these two powers and express this as 2 to the power of, I have 2x minus 1 plus 2x plus 2y, and that's equal to 2 to the power of 7. So now, if I just simplify this, it will be 2 to the power of 4x plus 2y minus 1 equals 2 to the power of 7. Once I have done that, now the bases are the same. I have 2 to the power of something is equal to 2 to the power of something. So once the bases are the same in this equation, if these bases are the same, the powers must also be the same. So I can now write down 4x plus 2y minus 1 equals 7, which I can then add 1 to both sides. 4x plus 2y equals 7 plus 1, which is 8. And to make it even simpler for us to deal with later on, I can see that there's a common factor of 2 in each of these terms. So I can divide the whole equation by 2. So 2x plus y equals 4. That's one equation that I formed from this part. Okay, now I can do a very similar thing with this now. Let me just move this stuff up there so I can have a bit more space. All right, so now what I'm going to do is I'm going to do a very much similar thing for this part here. So I have 9 to the power of 2y minus x over 27 to the power of y minus 4 equals 1. What I can do first is I can just make it a bit simpler to deal with. So 9 to the power of 2y minus x equals 27 to the power of y minus 4. Just multiplying both sides by 27 to make it a bit, get rid of the fraction. Now, 9 and 27. What number can I express them both as the same base? Well, 3. I know that 3 squared is 9, and I know that 3 cubed is 27. That's why it's a good idea for you to have an idea of especially the squared and cubed numbers and so on, and that will help you to answer such questions in a much quicker way. So I can do a very similar thing now. I can write 3 squared instead of 9, so 3 to the power of 2 to the power of y, 2y minus x equals, and this will be 3 to the power of 3 to the power of y minus 4. So I can multiply those two powers. So I have 2 times 2y minus x, which is going to be 4y minus 2x, and here 3 times y minus 4, which is going to be 3y minus 12. Again, now the bases are the same. I can equate the powers. So I can say from here that 4y minus 2x is equal to 3y minus 12. Now, if I subtract 3y from both sides, I'm left with, I can write it as minus 2x plus y, just subtract 3y from both sides, equals negative 12. And I've got an equation here, equation 2. So now what I can do is I can solve these two equations simultaneously. So I have 2x plus y equals 4, and I have minus 2x plus y equals negative 12. Now if I add these two equations together, the x's will become will be eliminated. All right, so 2x minus 2x is 0. Right? If I add 2x with minus 2x, I get 0. So I have y plus y is 2y, and 4 plus minus 12 is negative 8. So therefore y equals negative 4. And to find x, I can, for example, use this equation. 2x plus y equals 4. I know y is equal to negative 4. So I can say 2x minus 4 equals 4. So 2x equals 8. Therefore x equals 8 over 2, which is 4. So I'm left with x equals 4 and y equals negative 4 as my two answers to this question. All right, so there's the answer to this question. And if you wanted to check your answer, you could substitute these values into here. So we got x equals 4 and y equals negative 4. Was that it? Was that what it was? X equals 4? Yes. So if I put, for example, here 4 instead of x, I'm going to get 8. So that'll be 2 to the power of 7 times 4 to the power of, you have 4 minus 4, which is 0. So it's going to be 2 to the power of 7 times 1 equals 128. And that's true, because 2 to the power of 7 is 128. So this works for this equation, and for that equation, we'll have 9 to the power of, this is going to be 2 times minus 4, that's minus 8 minus 4, which would be 9 minus 12, over 27 to the power of, and that's going to be minus 4 minus 4, that's going to be power of minus 8. Okay, so if you want to check that, we can check that even using the calculator. Let's just make sure I've done that. 2 times minus 4, that's minus 8, that's minus 4 minus 12, and minus 4 minus 4 is minus 8. Okay, so we could even check that by sticking that in your calculator and checking. You have 9 to the power of negative 12 divided by, whoops, done it the wrong way around. Let me do that again. Over 27 to the power of negative 8. And that gives us 1, okay, which is what it has to equal. So we can verify that our answers are correct in the end by substituting our answers back into the original equation. So that's the question that is, I chose to put in the end of topic worksheet for this to do with equations, inequalities, and indices. Okay, and it's one of the questions at the end. So it involves exponential equations and also simultaneous equations. A bit more of an extension question, but it's well within what we should know for IGCSE work as well, even though it's from additional maths. So yeah, that concludes this question. Now, other questions from this paper, if I ever get round to do them. Now, some of these questions I might be answering even in my A-level worksheets, because sometimes I take questions from additional maths for the A-level worksheets as well. So you might find I answer the same paper, but in A-level end of topic worksheet. So the questions I do answer from this paper, I will put them in the playlist over here. And questions from this topic of indices and exponential equations from IGCSE, I'll put them in the playlist over here. And the questions from the end of topic worksheet that I'm talking about, I will collate them and put them in this playlist over here. So it's only the questions that the students ask me about from those things. I won't be answering the whole of this paper or the whole of the worksheet. Only the questions that students have asked me about, and I deem it kind of important to make a video about. If you want to subscribe to my channel, click on this link, and the card at the top here will take you to a video explaining how to use my channel to find what you're looking for from the different types of material I have. Thank you for watching, and see you soon.